Today we're going to talk about Netduino. We're going to talk about the new Getting Started with Netduino book, and then we're also going to talk a little bit about the brand new Netduino that was announced last week, which is called Netduino Go. So let's get started. I see we have a worldwide audience here, lots of people. Let's start out by talking about what Netduino is in particular. Netduino is an open source electronics platform. What this means is it means that it's a small circuit board that you can use to build your own electronics projects, whatever it is that you have in your mind. There are people who will get a Netduino and they'll blink some LEDs and they'll plug in some temperature sensors and they'll start interacting with the world around them, and that's kind of all they want to do. But there are some people who see their model train and they say, gosh, if I could just mod that so I could control it from my Android phone. People who say, I have a thermostat on the wall, but it really needs to be a smarter thermostat. Why don't I go ahead and hook it up to the Internet and make a client where I can change my temperature from anywhere in the world? And then there are students who just want to learn how electronics work. We're going to walk through that today and tell you how you can use Netduino and how you can learn how to build your own electronics projects for fun or for profit. So the first slide here, you see the Netduino family. On the left, we have the Netduino, the classic board. In the middle, we have the Netduino Plus, which adds in networking. And on the right, we have the brand new Netduino Go. This is a plug-and-play board that not only gives you the capabilities of the other Netduinos, but it also lets you just plug in pre-built components so that you can do electronics without any of the wiring. It's kind of our Uber platform. So the Netduino itself is a small circuit board. It's about 2 inches by 3 inches. If you had a deck of cards, you could set it on top. It would be about that size, roughly the size of a credit card. On the Netduino, you have what are called pins. On the top, you have 14 digital pins, and on the bottom, you have 6 analog pins, which are also digital. Now, what does that mean? When you build an electronics project, let's say that you're building a tweeting doorbell. Well, you need a network connection. That would be a digital signal. You need an analog signal, which measures the buzz coming off of the vibrator or the circuitry inside of that doorbell. And then you need some way to power it. Well, all of those things are built into the Netduino. This is kind of a general purpose, all-purpose platform to build that electronics project you want. Now, analog inputs at the bottom, those are for things like temperature sensors, anything where there's a level that you want to measure. If there's force that you want to measure, the level of a light, the level of humidity, the amount of water that's in a plant, those are the things you can measure there. At the top with the digital I/Os, you can control things which are on or off, like a light, or you can take inputs that are on and off. Let's say a sensor which senses when a door is closed, or a push button that's being pushed. The other thing you can do with the digital inputs and outputs is communicate with other microchips. So let's say you have a network connection. You could plug in a networking chip. If you had a Zigbee chip to interact with a home automation system, you could plug that in. And if you had a GPS receiver, again, you can plug in that serial connection on the top. There's lots of power here. If you look at the Netduino, you'll notice that it doesn't have a network connection, and everything in our lives these days seems like it's networked. If you have an iPhone or an Android phone or a Windows phone, you have a whole family of apps that can control the world around you, do augmented reality. It's a world of possibilities. Well, what if you could build your own electronics bridge that brought that networked world into the real world? Well, here with Netduino Plus you can. If you notice on the top left, there's an Ethernet jack. You can plug this right into any network connection. And now that electronics project that you've created is live either on your local network or on the Internet at large, and you can control that. There's also a micro SD card slot at the bottom. You can use this to store data. You can use that data to serve up miniature web pages or a simplified web server, or you could actually store data there. Let's say that you had a system of Netduinos that were in the field collecting earthquake data or Geiger counter information. Well, you could take that information and you could then store that to a card which could be retrieved later. The next Netduino is the brand new Netduino Go. And as you can see from the system, it's a plug-and-play system where you can plug in individual components. You have 8 sockets. Any of the 8 sockets can take any Netduino Go component. And these are made not only by Secret Labs, the creators of Netduino, but by members of the Netduino open source community. We'll talk about that in a moment. Now, you remember on those other 2 Netduinos I showed you, the Netduino and the Netduino Plus, that you had the digital and the analog inputs. Well, you have that on Netduino Go as well. If you look at the back of this picture, you'll see that there's something suspiciously looking like a Netduino plugged into the Netduino Go mainboard. Well, that right there is what's called the shield base. Here's a close-up of it. On the left, you'll see that it has those analog and digital inputs and outputs, just like a Netduino. And you can plug the same kind of components and expansion boards into it, like the Maker Shield from MakerShed that's on the right. We'll come back to this in a moment. We'll start talking about how to use Netduino. We've talked about the hardware now, but really, much more important than the hardware is what Netduino is really about. It's not about the hardware. That's the secret here. What Netduino is about is the people and the community, the projects they can build, and the tinkering and the learning that each of us can do with the platform. So let's talk about Netduino. Who is Netduino? Well, as of today, there are over 14,000 community members that have joined in the last 18 months since we launched Netduino. 6 continents, 1 community. It's a very fun community, and people are helping each other out on a given day. There's people in the chat room talking about projects they're working on. There's people posting to the forum, showing off their projects, asking questions, helping each other out. Let's see what some of these community members have been up to with Netduino. The first one is Andreas Schneider, who's, I believe, from Europe. He decided that he needed to internet connect his coffee machine. The trouble with knowing when you have to go over the coffee machine to start brewing, how to get the perfect coffee or espresso. You know, coffee and engineering seem to go hand in hand so often. So he hooked up a Netduino Plus to the interface into his coffee machine, put it on his intranet inside of his network so that no one was making coffee from the greater internet at large. And then he built an iPhone app, which lets him specify the brew time, the type of coffee, and actually make the coffee right there from his iPhone. Now, if you look at the bottom here on each of these slides, we've included the link to the video. So if you come back to this presentation later, you can actually grab these links, go visit the YouTube videos of these community members who have built these awesome projects, learn more about them. Many of them have even shared the code for what they've built. Netduino is all about not only what other people have built, but learning from what they've built, building on it, and either deriving small parts from it into your own projects or creating the Uber coffee machine, going to the next level. Now, let's look at another project. Here's one from Chris Hammond. Now, Chris Hammond, I believe, is Director of Training at .NET Nuke, and he built another cool project, which was a foosball tracker. Very important at an engineering firm again. But this is another project I'll show you here that he had built. There's a lot of things with motors and wheels in this world, and Netduino is perfect for those. You can create a robot that follows lines, navigates different terrains, is remote controlled. Well, here he's taken the first step, took a Tamiya tracked vehicle. There's a Netduino on top that you can see, and then he's programmed it so you can actually control it. Now, you could hook this up via wireless connection, and you could actually drive it around the room. There's a whole world of capabilities. And once you have that robot base, you can either drive it around for fun, or you can attach cameras to it. You could attach cliff sensors so that it would go up to a stair and it wouldn't fall over. Any type of application that you have, whether it's a remote security bot that you could run around your house or to check on your dog while you're away, all the way to a bomb disposal robot if you want to derive something from a Netduino and create commercial applications. There's a lot of things you can do. In fact, this tracked vehicle is a lot of fun, and I've seen a few of these. I've seen people who have taken Chris's work and taken it to the next level or have built something with another tracked device. Let's talk about one of them here. There's a group called Tech Junkies, and Eric Barch put together this video. He works with a couple of his friends, and they made the Mantis bot. Now, this is a really, really kind of souped-up Netduino-powered robot base. It has Wi-Fi. They actually put a Wi-Fi router on it. They painted it. And it has 4 speed controllers, 4 motors, a huge circuit breaker, and a 12-volt car battery. This thing is so powerful, they actually, in their video, they'll show you it pulling them around, sitting on a skateboard, and it's kind of taking them around the parking lot or down the street. They built an Android app for this so they can control it, and it just has virtual joysticks, much like you'd have on an Xbox controller, but just on the screen. And this is just a robot base. So as you can see here, it can climb up the curb. Well, if I've created a road base which can climb up the curb, why can't I put something on top of it? Why can't I take this to the next level, build something else out of it? Tinkering and hacking and building things, learning how things work, and going from there is what so much of Netduino is about. Speaking of wheeled things, I don't know if you saw West Coast Customs. There was a episode on TV, I think it was last week or the week before. Microsoft took a Mustang. They actually took the body of an old Mustang, put it on a brand new Mustang's base, and then they put all kinds of technology inside of it. In the front dashboard, they put a Windows, I believe it was a Windows 8 tablet, and it had the display of the odometer and the speedometer and all the instruments of a modern Mustang, but you could swipe it to the left and it would show you the retro one. Then you could swipe it again and it used the Metro theme that Windows 8 and the Windows phones use. And they put all this tech. One of the biggest cool pieces of tech they had was for tailgating. They have a big screen. The rear window actually comes up and turns into a huge display. And then they have all this cool lighting in the car. Well, when it came time to do that, what did they turn to? Well, they turned to Netduino Plus. So there's a Netduino Plus. If you look at the right side here, it's tucked away on the bottom left side. But it's controlling the lighting and the motor control for this back glass window. There's a Windows Phone app that interfaces with this. They've got cameras in the car. And all these things, including the Netduino Plus, talk to a central computer. Now, when they created this, and we'll talk about this in a few moments, they used C# and the Microsoft.NET Micro framework. What this allowed is allowed any of their developers, much like millions of software developers around the world, to use the skills they already had to integrate electronics into their phone project, into their desktop project seamlessly. Now, you can go and you can build lighting for a car. You can build robots that walk around. You could build your tweeting doorbell or your breathalyzer, your animated dance floor, your Pinewood Derby track timer. I've seen people who created Halloween costumes and they had dead mouse masks they put on. There's a million things that you could build, and we can talk about more of those later. But some people feel that the best projects involve danger or fire. So let's show you some of those. Oh, I guess I should share this first. Be a professional, learn how to do things safely, and don't hurt anything. Here's a note from legal. So here's someone who wanted to build a CNC machine. If you aren't familiar with CNC machines, they cut things, often out of wood or a different type of material. Well, here someone said, I want to build a CNC machine that can cut objects out. I want to build it using an Arduino, but I don't have the parts. So Darren actually built a CNC machine using parts cut by the CNC machine he was building. So he took it from, let's build the basics so that we can drill out parts. And he got it just barely working. And then he had it actually build part after part to build his full CNC machine from scratch, which is just really, really impressive. Another community member here, and this one's really funny, Dan Thayer, who works, I think it's Logical Advantage is the name of the company. He has built a number of projects. The first one, and this is one of the dangers in Netduino, is you start with a simple project and then you keep on needing to one-up it. You find the next level to go to or something else you want to play with, and you can reuse the same hardware over and over. Well, he started out by seeing his pool and saying, gosh, there's this Kinect controller for Xbox, and I can point at different places, or I can wave my arms, and I could point a squirt gun based on the position of my arm. So he hooked up his PC to a Kinect controller, and then he hooked up a Netduino Plus in his network, or a Netduino with a wireless link, to a squirt gun and motor controls. And he stands on his porch, and he actually moves his arms. And you can, if you go and look at Logical Dan, and you look at YouTube, you'll actually see this video. And he can spray different parts of his pool just by simply aiming with his arms. It's pretty hilarious. Well, he needed to one-up that. So he said, well, why don't I do speech recognition? And so he took that Kinect and that Netduino, put them in his car and in his garage, and then made it so when he came home he could talk in his car, and his garage door would open. Well, that's all fine and well, but the ultimate is, I guess, fire, apparently. So here he decided to create a self-destructing QR code. If you look in the fireplace there, you'll see a huge QR code. And when he scans it with an app on his phone, the phone starts counting down from 10. When it gets to 0, it sends a signal, which opens, I believe it's a solenoid, that controls the fireplace. Do not do this while you're away, of course. Be careful. But it's a self-destructing. It actually lights on fire. You gotta watch this video. And that was the kind of the logical conclusion of where he goes next. I can't wait to see what Dan comes up with next. Now, in addition to people who are building stuff in the communities, the robots and the Minecraft timers and the cool sprinkler systems, you have people who actually build hardware in this ecosystem. You have companies like Adafruit who create shields. You have companies like MakerShed, which is owned by O'Reilly, who sells this open source hardware and a lot of cool kits and projects. You also have developers and engineers and tinkerers who build hardware and then sell it. There's a whole ecosystem. Now, Netduino is what's called open source, not just open source software, which you may be familiar with from, let's say, Linux, but also open source hardware. So the operating system and the runtime that runs on the Netduino is called .NET Microframework. And what .NET Microframework is, it's a version of the programming language runtime that Microsoft creates for phone apps and Xbox games and desktop apps that they've taken and they've put on tiny little microcontrollers. And for the existing Netduinos and then now for the new Netduino Go's, someone has taken that language and made it work on a specific type of microcontroller. Well, all of that's open source, which means you can grab the source code and you can dig in as deep as you want or as shallow as you want to learn how it works, to modify it, to use it in your own projects, your own work projects. There's no license fees. It's completely free. It's a community of people who are building and improving it. Well, we want to do the same thing with hardware. So the Netduino hardware is open source. You can go and you can buy a Netduino, or you could actually download the design files, send them to a PCB manufacturer, get a circuit board, buy all the parts, and assemble it yourself, and then still participate in the community. It's a pretty cool concept, and what we see is people take those designs and then they turn them into commercial projects, or they say, I need a Netduino for my robot, which needs to have ruggedized connectors or XYZ, and they can go and they can derive from the designs, no royalties. All they need to say is, this is derived from Netduino, and they're free and clear to go and create those. Those licenses are Apache for the software, which is an industry standard open source license, and Creative Commons for the hardware designs, which is kind of like public domain, but we just ask that you say, hey, this came from the Netduino project. Well, here in the Who is Netduino section, let's talk about Fabien Royer and Bertrand Leroy. I think they'll be joining us a little bit later for our Q&A session. They've actually created kits and modules that plug into your Netduino. On the left here, you see that there's a little gaming console, and they said, gosh, let's teach people how to play games. And instead of focusing on some really complicated screen and all the rasters and bitmaps and everything else, let's give them an 8x8 screen and let's give them some sample games. So they have paddles, which looks an awful lot like Pong, and they have one that looks a little bit like Asteroids. And I've seen some third parties, some community members who have created some different games for it. It's a lot of fun. It has a little Netduino Mini, which is the Netduino we didn't show you earlier, but it's a tiny little chip version of the Netduino you can plug in. And they actually sell this off their website at noisette.com. Same for the other two. The other two aren't kits. The one in the middle is a relay. This plugs into the Netduino Go board so that you can turn on and off high-powered devices like lamps or appliances. Use careful precautions and everything when you're doing that because it's high voltage. But that's a lot of power that you can use there. And then on the right, you have a touch display so that you can create a graphical interface. Plug in your Netduino Go, plug in some RGB LEDs or relays, your different interface components, and now you've built yourself a cool project that has a touch interface on it. But these two guys, Fabien and Bertrand, actually used to be software developers in the corporate world, and they quit their corporate jobs to focus on open source hardware and open source software. So here's a success story of people who are seeing Netduino and seeing opportunities, not just for fun, but also for something they can do that they really enjoy and they can do full time. So the last important group here in the Netduino community, who is Netduino, are the community volunteers and code contributors. And here are just three that I pulled that are some of our biggest contributors. Stefan Thulin, who couldn't be here today, but he's our main moderator on the Netduino community. He takes care of people, and he also had a lot to do with the new Netduino Go main board. We'll talk about that later. David Stetz, who spent hundreds and hundreds of hours as free evenings and weekends since probably September of last year, actually porting Microsoft's .NET Microframework to work on the new microcontroller family used on the Netduino Go. Just amazing contributions that people are doing because they love the community and they want to promote open source technology, and they want to share with other people. And then Stanislav's hilarious. He doesn't have a Twitter handle. I put redacted because I didn't know what it was. Apparently he doesn't have one. I've never actually seen him. He takes videos, and all I ever see are his hands. He's a little bit secretive. He values his privacy, but he wants to help. And he actually created a lot of the firmware for the new Netduino Go modules, the potentiometer, RGB LED. They all have little microchips on them, and he took care of a lot of that and just contributed to the community. He's also doing reflashing apps now and all kinds of stuff behind the scenes. These are the unsung heroes, but this is what makes open source work, is people who build things, but some people who just want to give back, and you're welcome to be on either side of that fence. So that's the Netduino community. That's who Netduino is. It's 14,000 plus community members, and hopefully after this call, if you're not already, also you. Welcome to the journey. Welcome to Netduino. We hope we can build cool stuff with you. All right, so let's talk about how to build stuff with Netduino, because that's what all this is about, getting started with Netduino. To get started with Netduino, you need two things. You're going to need a Netduino, and you're going to need the free tools. Microsoft provides two programming language options, Visual C# and Visual Basic. Today, Visual C# is fully supported. Visual Basic is supported in beta on the Netduino, Netduino Plus, and in production on the Netduino Go. We'll talk about the book in a moment. The book is geared toward the Netduino and Netduino Plus, but we'll actually be providing an update here soon for the Netduino Go so that you can use all the samples, just a few small things you'll need to watch out for. But we did design the Netduino Go with the book in mind to make sure that the skills that you're learning and the examples that you're creating will work going forward. One important thing about Netduino is you can start anywhere in the Netduino world and then go down or up. You can build a project with the cheap $35 Netduino, and then you can use the nice Netduino Go for all your prototyping, and all your code is portable across the entire family. So that's what's required. What's recommended is the book, and that's what we're here mostly to talk about today. Now, in the book, a lot of the samples use what's called the Maker Shield, and if you're comfortable with a soldering iron or you're willing to learn, the Maker Shield's an awesome way to use the samples in the book. So it gives you a potentiometer, which is like a little volume knob, so that you can measure the level of it. It gives you a push button and some LEDs. Gives you a prototype area you can put a breadboard down on, and it makes it really easy to test out a lot of the samples and experiment with Netduino. If you're not comfortable with that, you can just go with the book, maybe pick up the Maker Shield for later when you are comfortable with a soldering iron, or just pick up the book. And we'll walk you through the examples on a breadboard. No matter where you're at, solder, no solder, there's a place in the Netduino world for you. So let's write our first app. And we've actually prepared a video for this, and the video is on YouTube, so you can watch it later as well. And we're going to start that here right now, and I'm going to walk you through how to blink an LED. For those of you who have seen it before, I'll be on chat for about 4 minutes while we're going through the video. This will be pretty quick.
Okay, we just got our Netduino. So let's make our first Netduino app. Go to the Start button, Programs, Visual Studio 2010 Express, and let's launch Visual C# 2010 Express. When it starts here, let's create a new project. We click New Project, and we're going to make a Netduino app. Now, it's already selected, but if it wasn't, we can select Micro Framework under the Visual C# category, and then Netduino app on the right side. Now let's name it. We're going to call it Blinky, because we're going to blink an LED. We press OK, and it creates our app. Now let's get started. On the right side, you see all the files inside of our project. Well, program.cs is our main code, so I just double-clicked on that, and it shows up over here. Most of the time, you're just going to write your code inside of main, but you can have multiple files in a larger project. Click underneath where it says Write Your Code here. Now to control the LED, we need what's called an output port. An output port lets us set the voltage on a pin or on an LED on the Netduino, either high 3.3 volts or low 0 volts. Doing this will turn our LED on and off. We'll call this LED, and it's a new output port. Now we're going to type pins dot, and when I push the period, you'll see this nice list, which I can scroll down, of all the different pins on my Netduino. A are for analog, and D are for digital, and then at the end here, you'll see the onboard LED and switch. We're going to pick the LED, and if I double click on that, it'll automatically type it. The initial state is whether the LED is on or off. False is off. True would be on. We'll start with the LED off. Now we want to blink the LED. We want to turn it on and off repeatedly. The easiest way to create a loop, to do things over and over again, is to use while true. We can explain this in detail later, but basically anything inside the parentheses is evaluated to see if it's true. It could either be an expression or just the word true. Because it's the word true, this loop will never end. Inside of these curly braces is our code for the loop. Our first bit of code is to turn the light on. So we say LED right true. This turns the light on. Then we're going to sleep for 250 milliseconds to leave the light on for a bit. Then we'll turn the light off with LED right false. And again, we'll sleep for another 250 milliseconds. Add these together and we get half a second. So the light should blink on and off twice a second. We're done. Let's run our program. Now by default, Visual Studio uses what's called an emulator for the micro framework. A lot of professional software developers want to get started on their programs before their hardware arrives, so they use the emulator. In our case, we already have our hardware. There's no need to use the emulator. So let's switch to using real hardware. We go to Project, up top, and select Properties. On the left side, we pick the .NET Micro Framework category, and then here you see the deployment device. By default, it's the emulator. We're going to change the transport to USB because our Netduino is plugged in via USB. Our device already shows up here because our Netduino is plugged in. If it weren't, go ahead and plug it in now. If it doesn't show up, just change it back to emulator and then back to USB again, and you'll see your device. Now let's close this to make sure that Visual Studio recognizes our changes. And now let's run the program. Up at the top you see a play button. It says Start Debugging. You can also press F5. When we press this, our Netduino app will be deployed to our Netduino and start running automatically. It's pretty quick. Let's do it now. I'm going to press the button, and you see down here, it's deployed and it's rebooting, and now it's running. Alright, let's see what's happening on the Netduino. And there we have our blinking light. That's it. We've made our first Netduino app. Thanks for watching.
So thanks for watching that. That was the first sample that's actually in the book as well. With the Getting Started with Netduino book, we wanted to make sure that we took you from blinking an LED, which is kind of your typical first thing you do with a microcontroller board, all the way through building an internet-connected gadget of some sort. And for reference, that was about 3-minute video. With a traditional microcontroller board, like if you bought a PIC board and you had never programmed it before, it's not unheard of to spend, if not hours, days, or even for some people a week or more, just getting an LED to blink and getting everything set up right, making it work. With .NET Micro Framework and C# Visual Basic, the programming languages that you can use on these boards and the power that's there, it's so simple to get these things up and running. If you're a developer who had an EE class in college and you never had a chance to really use that, but you want to go back and play with that some more, you can step right into Netduino. If you are a developer who's never touched electronics before, you already have the skills, just plug in the Netduino and plug in an LED, and gosh, we've got something blinking. And that code that we just used to blink the LED on the board could work equally as well to blink an LED that's plugged into one of those digital I/O ports. Well, in the book, blinking an LED is fun and all, but it has a limit to its usefulness. There are a lot more interesting things to do. So we walk you through how to use a push button. So when you push the button, we light up an LED. When you let go of the button, LED stops being lit. A potentiometer, which is that little volume knob like you saw on the Maker Shield. We show you both on the Maker Shield and on a breadboard. We use it so that you can control the brightness of an LED or maybe change the blinking speed of one to emulate that. Another feature that the digital pins on the Netduino have is to be able to change the intensity of a LED or to change the speed of a motor. In fact, motors and servos, that's another thing we cover. And the book doesn't go into motors in a lot of detail because motors are pretty simple. You use what's called the PWM feature, and you say, I want this to run at 0% speed or 100% speed or whatever percent in between. It's not that difficult. You use some external componentry, often built into one of what's called an expansion shield that plugs in on top that takes your PWM signal, combines it with a bunch of power, and turns it into an analog voltage, which can drive the motor at a respective speed. We talk about servos, which is more interesting because now you can move things to certain positions. If you had a sign that you wanted to turn, or a plasma lift, or that window in the back of a car, for instance, you wanted to go to a certain position, well, a servo gets you what's called a feedback loop. You know where that servo's at, and you simply use a pulse signal, and you don't have to sit there, 10,000 times a second pulsing that signal and changing the length of that signal so it knows what position to go to. You just write one line of code, and it just starts moving. It's really simple to implement. We do a piezo buzzer. We play a childhood tune, and then we finish up the book before the troubleshooting or upgrading sections, things like that. In the end, we finish it up by showing you how to take that LED you started with, connect it to the internet, and now you can use a web browser to turn that LED on and off. And now you have kind of all the pieces that you've got started with that you can go, gosh, I know how to use a motor, know how to use the internet. Why don't I create a internet-connected plasma lift for my TV? And I know how to use LEDs. Why don't I build an LED cube? Or why don't I take a stoplight, like one you could put up on a wire over the road to control traffic, put it in our cafeteria, and I can signal when food is ready for people. There's all these cool things that you can do. Now, after you've gone through all those experiments and gone through the book, and that's about 100 pages of content, there's a million places you can go with Netduino. Here are some expansion shields. I mentioned Adafruit earlier. They make expansion boards that work with both the 8-bit Arduinos and with Netduinos as well. On the left here, here's a motor shield. I talked about that a moment ago. It takes your signals and amplifies them so that you can turn motors. In the middle is a data logging shield. You can use this to record data on an SD card. Now, the Netduino Plus has micro SD on board, and you can use that to store data or read data back. But with the regular Netduino, you might not have that. Well, you can plug in this SD card reader. You now have that capability, plus it has a real-time clock that's battery-backed, which means it keeps time even when your Netduino doesn't have power, much like your laptop. If you take the battery out and put it back in, it still knows what time it is. Well, if you're building an earthquake sensor out in the field or any type of device like that, you want to know what time it was to record that data, even if the thing gets unplugged and plugged back in. On the right side, you have a GPS receiver, which technically you could pull the time from, but it's great for position data. If you build a rover that moves around, or you're building a game that involves geolocation, well, there you go. You go your GPS receiver right there. And there's pre-built libraries and drivers for this. And when I say the word libraries and drivers, I don't mean something complicated. I mean just code that looks like any other code for Netduino that's wrapped up, that's created by members of the community and provided for you. And since Netduino's been on the market for about a year and a half now, a little bit more than that, there's drivers for all kinds of expansion boards. There are literally 100-plus expansion boards that work with Netduino, plus there's hundreds of thousands of electronic components. Kind of the world is your oyster here. If you have an idea for what you want to build, come join us in the community. Let us know. We'll be happy to help you out and kind of tell you where to take it next. That's the book. That's getting started with Netduino. We take you from blinking LED to motors to servos to piezo speakers and sound, all the way to here's how to create something with the internet. Of course, for that internet connection, you'll need a Netduino Plus. Well, let's take it one step further. We have this exciting announcement next week. We have something new. It's called Netduino Go. In the Q&A session, if you have some questions, I can tell you, or our other experts, we'll have a couple here, can give you information on it. But let's talk about this a little bit, because this is kind of the Uber platform for Netduino, but it's also designed to bring Netduino and open source electronics to a crowd of people who might not feel comfortable with a soldering iron. It kind of is the best of all those worlds. Now, how we've accomplished that, and we can deep dive in this during Q&A if you'd like, is we've done something called virtualized input and output. Basically, when you look at the Netduino, it has a microchip on it, and there's a bunch of pins coming out of that microchip, little wires connecting the circuit board. Well, each one of those is either power, or maybe it's keeping time, or it's one of those digital inputs, or it's an analog input, and they go out to the headers on the side. A lot of them do. Well, you only have like 64 on the Netduino Go, yet we might want to be able to plug in 100 or more different digital inputs or analog inputs. Let's say we're not satisfied with just 6 analog inputs. We want 24. Well, with Netduino Go, you could plug in 8 3-analog input devices, or one that had 24 on it. Here's the shield base, which looks a lot like the classic Netduino and Netduino Plus, and it gives you those 20 digital inputs, outputs, 6 of which are analog inputs. You simply plug it into the Netduino Go, and now you have those same kind of capabilities. Now, this is in beta. This is brand new. In addition to the Netduino Go, which is production hardware, as are its modules, we wanted to come out with kind of a showpiece for it, and this is it. This will be coming out of beta late spring, early summer. But you can still plug that expansion board into it. There's the Maker Shield with a breadboard on it, and we'll be enabling scenarios where you can plug in the GPS receiver and all these kind of components that you're already using in the Netduino world. You can plug it right in the shield base. As we take this out of beta, we'll also enable plugging in multiple shield bases at the same time. So let's say you didn't just want the 20 inputs and outputs. You wanted 40. Plug in 2. In theory, you could plug in 8 of them. Your only real limitations are speed, memory, and the amount of power you have. The same kind of considerations you have with an air conditioner of how big of a room it can cool because of the amount of power it has and the size of fan in it. Or a computer, the size of the power supply, the amount of RAM. You're not limited by anything except for just your physical resource limitations, which are normal limitations. Here are the modules that we launched for the Netduino Go. We call these Go modules, and you'll see at the top from left to right you have the RGB LED. Now, we paid a lot of attention to all the detail, not only in the software but also in the hardware. If you look at these, we're using really, really nice parts. The RGB LED uses an Avago high brightness outdoor viewable LED. This is the kind of LED that's a pixel, has red, green, and blue inside of it, that you'd see in like a big outdoor beautiful display. It mixes colors beautifully. It's just absolutely gorgeous. We had to limit it to about 1/3 brightness in software. You can take off that governor if you'd like, but just so we didn't hurt people's eyes. In fact, our beta testers, the first things they said was, my eyes, it's burning my eyes. So we toned that down for production in software. In the middle, there's a push button, which you simply push and release, and it gives you events in your code that push and release. On the right side, you have a potentiometer, which is, again, that turn knob so that you can measure the level of voltage coming from that. But instead of dealing with it as voltage, you simply say, I'm at 50%, I'm at 100%, and you get that in code. You say, get the value from it, and it tells you I'm at half. And we'll show you a code sample for that in a moment. On the bottom, you see again here the relay module and the display module from Noisette. And then there's dozens of additional modules that you'll see over the next year shipping. There's a piezo buzzer coming soon, an Ethernet module, SD. I've seen gyro plans and everything else. So you'll have lots more to play with in addition to the typical things you can plug into a Netduino via the shield base. Now, let's give you a few samples for this, and then we're going to do Q&A on everything related to Netduino. We can cover the book. We can cover Netduino Go. We can cover open source. We can talk about pretty much whatever you want to talk about. But let's give you a few samples with Netduino Go, because I know a lot of you tuned in to learn more about this platform. I'm going to give you 3 quick samples. The first is a button press. So for this, you'll need a Netduino Go and a button module. Now, there's a little cable that goes between those. You get 2 for free with your Netduino Go. If you want more, they're like $2 a piece. They come in 5 packs. The starter kits come with 4 cables and 4 modules, so you have enough to plug in everything that comes with the starter kit. So we plug in that button, and there's 8 sockets. You can plug into any of the sockets. It's just like USB. You plug it in. You don't worry about where you plug it in. It just works. Your code looks like this. The first line of code, we just say Netduino Go button equals new button, which just finds the first button on the bus. If there's a couple of them, it'll find the first one numerically on the bus. The second line of code, we say whenever that button is released, I want to call the button released event. With typical microcontrollers, you have what's called a control loop, and you just go around in a loop over and over and over again, analyzing variables of data that's coming in, and then taking that information and doing something with it. So you say, have I moved as a robot? Yes. Okay, where have I moved to? Now let me take that information and act on it to keep myself on course. But as your project gets more and more sophisticated, as control loops get more and more heinous and it becomes harder to weed out bugs and all this kind of stuff. Well, with .NET Micro Framework and with Netduino, everything can be event-driven, where you simply say, when my button's released, go run that code over there. And you could create a GPS driver that said, when I've moved more than 50 feet, run that code over there. And you have multiple things happening kind of at the same time that are all independent, and you don't have to worry about a lot of those traditional microcontroller programming issues. They're just taken care of for you. Now the event at the bottom, whenever that button's released, debug.print button has been released, it actually writes that out to your Visual Studio programming environment, so you're getting information back from the board, and you actually see that button was released in code. The thread sleep timeout infinite just tells it to keep the program running, so when the button's released, it can give you that information. The next sample, we're going to do a color tuner. What the color tuner is going to do, we plug in 3 potentiometers and an RGB LED. And as you turn each one of the potentiometers, it adjusts the red, the green, or the blue value. So you can pick from 2 to the 24th colors, like 16 million different colors that you can represent with a RGB LED on Netduino Go. So the code for that, again, is pretty simple. We don't even have to specify the socket for the RGB LED. You could if you wanted to. For the 3 potentiometers, it would find them in order, but we're going to specify the socket numbers here because we want to make sure that the one on the left is red, the one on socket 2 is green, and the one on socket 3 is blue. So when we create that potentiometer, in parentheses, we type go sockets.socket 1, socket 2, socket 3. That's all we have to do to specify where that is located. And then we're creating a while loop here so that we just do the same thing over and over. And we're simply getting the red, the green, and the blue values. Now, the potentiometers, we use get value to get the value of the potentiometer. And it's a value between 0 and 0.99 something. And these numbers coming back, they're decimal values, they're fractional values. So we have to turn them into something that's a color. If you look at the colors on the web, all the red, green, and blue values are 0 through 255. Well, here we're multiplying them all by 256 so that we get a value in that range from 0 to 0.99 turns into 0 to 255. And then we simply set that color on the RGB LED. We didn't need to know anything about resistors. We didn't need to know anything about current limitations. We just plugged the components in. We wrote a few lines of code, and now we're off and running with a project. And guess what? If you want, you can go and you can build your own RGB LED implementation, wrap it, use the same code. You could actually take this code and drill down a little bit more. We'll be providing an update for Netduino Go where you could actually run code inside the microcontroller on the module to adjust the LEDs using that PWM object that you'd use on a Netduino. There's a full continuum of capabilities and code portability built into Netduino so that it gives you the ultimate freedom to create whatever is in your mind that you want to create. And whenever you learn something new, you can reuse that skill. The third sample here I'll show you is really simple. It's shield base I/O. And we're going to take a Netduino Go, plug in a shield base, and then I pulled this yellow LED, the same one you'll see on the cover, off of the MakerShed web store. Now, normally I'd recommend that you plug in a resistor in line with your LED, and that's something we'll talk about in the book. If you don't know what that is, don't worry about it. It's not a big deal. But it limits the current going through LEDs so you don't burn out the LED or accidentally burn out a pin on your chip. With one LED plugged in, it's generally not an issue. We actually show it on the cover that way, and electrical engineers will chuckle a little bit. That's not the best engineering practice, but that's how we'll do it here. So I'm plugging in this LED into the digital 13 pin and into ground, and then I'm plugging the shield base into socket 4 on the Netduino Go. My code looks almost identical to what it would be on a regular Netduino. The first thing I do is I create a shield base object using socket 4, and this makes it so I could have multiple shield bases plugged in the future. The second line of code, I'm creating the output port, just like I created in the video for the LED. Instead of saying pins.onboard LED, I say shield base, which specifies which shield base it was, because that's what we called it. .pins.gpio pin D13 works exactly like it would with a native pin on the microcontroller. We virtualized the input and the output, so your code doesn't have to change. You can simply pass in a pin that's on a shield base or whatever other type of device that's an expansion I/O module, and it works as if it were the LED that's on the board. And then we blink the LED, and we're simply reading in the value of the LED. There's an exclamation mark in front of LED port that reverses that value, and then we're writing at that reversed value. So in the loop, we read that it's off, and we turn it on, we sleep. We read that it's on, we turn it off, we sleep. And we just go around in circles this way. And now we've taken our blinky LED sample, and we've used it with Netduino Go. That's Netduino Go in a nutshell. I'm going to talk about one more thing with Netduino Go, and that's how we got here. Community innovation is a big part of Netduino. We listened for the last 18 months to the feedback from the community and everything from the DC-DC, switching power supplies that's in Netduino all the way to the USB ESD circuitry and the software that's running on it, a lot of the capabilities of the platform, the USB connectivity, the way the sockets are working, the plug-and-play on the shield base, the capacitors. There's a lot of details, and we can go on this in Q&A or you can ask on the forums. that came from community feedback. But even more important than that community feedback and learning what people were using Netduino for is the community members themselves. Stefan Thulin last year talked to me and said, hey, I've been thinking we need to have Netduino with components. And I said, hey, we've been thinking the same thing. We had seen Microsoft's Gadgeteer research project the same day we told them about our plans for a component kit. And we thought there's a lot of great ideas out there, what Arduino's done with Tinkerkit, what Parallax has done with their systems. Why don't we kind of pool all the best ideas from some of the top community contributors and build something that's really stellar? And here you're actually seeing a prototype that Stefan built. He's in Holland, and he built this. There's shift registers, and there's dip switches. There's a button module on the right and an LED module on the left. The board in the middle is actually a shield that plugged into an Arduino. Then you see a bunch of LEDs down the left side, just like the blue LEDs that are next to each socket on the Netduino Go. And this works. And he can use the same code to actually turn on and off a blinking LED, or turn on and off an LED using the push button, blink the LED, whatever he wants from code, just like you can on Netduino Go. And he was able to test this and prototype it and come up with ideas. And as a community of a few people from the Netduino community, we went and we iterated into this new platform, and that was a community contribution. So for Q&A here, I'd actually like to invite a few of the people who were involved in the new Netduino Go. Stefan can't be here today. He's in Holland, and it's late there, and he had a prior obligation. David Stetz is the gentleman who spent a lot of time building the port for the new microcontroller for Netduino Go and the shield base. He's an unsung hero here. Stanislav did the module, firmware, and update utilities for the modules, and Fabian and Bertrand, they are making hardware for this platform. Some of them may be on the call. I'm not sure here, but if they're not, they'll be in the chat room. At this point, we're going to take Q&A questions. We'll answer them the best we can. If we can't get your question answered here, you're welcome to take it to the forum later. Just to review, we've taken you through how to blink an LED. We've talked about the book, which takes you from there all the way through motors and to Internet-connected gadgets. We've told you what Netduino is and what you need to experiment with Netduino. We've talked about the micro framework, and we've talked about the cool things you can build, like LED cubes and robots and tweeting doorbells. Let's open this up for questions and answers now. I thank you very much for joining us, and we'll go from here. Yas, do we have some good questions there?
Yep, thank you for a great presentation. We have several questions that have come in, and folks attending today, we want you to know, please, if you have questions, keep them coming. Open that group chat widget, type your questions in, and send them in. Real quick, let's see. Gentlemen, do we have you on the phone with us?
We're here. We're here.
Great.
Fabian Bertrand, welcome.
Yes,
hey.
So glad to have you. Okay, let's take a look at some questions. We'll just take them in the order they came.
A lot of questions.
Yes. We'll start at the bottom here. Question from Jason. Jason asks, can 8 shield bases be plugged into the Netduino Go?
Well, let me answer that one really quick. The answer is qualified yes. Right now for the beta, we've limited it to one module. We're making sure that everything's working well before we amp up the speed and do a lot of performance tuning and then make it so you can plug in 2 and eventually 8 of them. The only limitation you really have is power eventually. When you have 8 shield bases, you might start needing to plug external power into things because with 500 milliamps of power, you aren't necessarily going to be able to power divide 160 different things that are plugged into all your digital inputs and outputs. But yes, absolutely, the architecture is designed to support 8 of anything that you plugged in, 8 RGB LEDs, 8 GPS receivers. As long as you have the milliamps, the actual amount of current to power those things, you're fine. And the DC-DC power switch that's on the main board is designed to turn the 500 milliamps of USB power into more than that in 3.3 volt, which is what most of the things in the system run on. It's very power efficient. It runs pretty cool.
Great, thank you. Our next question is coming from, let's take a peek here, from Ken. Ken would like to know, is the Netduino an Arduino that is network capable, or is there more to it than that?
That's a good question. Ken, thank you for asking that. So Arduino is a fantastic open source project started by some teachers and students originally in Italy, and now they've kind of gone worldwide with it as well. It's 8-bit. Netduino is 32-bit. It's based off the AVR platform, and it's a great platform for hackers and tinkerers as well. With Netduino, we kind of approached this from the other side. It's a completely different board, completely different platform. We wanted to make something for engineers and students and people who are technically minded and want to use world-class development tools that are all free and want to build stuff. And we put extra circuitry on the board, so not only is it the same size, but it actually will work with most of the same expansion accessories. But they're not two members of the same family, but they're two brothers in spirit.
Great, thank you very much. Question now from Travis. Travis says, I'm okay with Arduino, but want to interface with the web. Should I use Netduino or Arduino with Ethernet Shield?
I'm probably a bit biased for that question, but if you're using Arduino today and you're happy with that, there's no reason that you need to change. Netduino is designed for the Internet, though. Not only do you get some really fast networking, Netduino Plus has about 1 megabit per second. It's blazingly fast, over 7 times faster than almost anything else you'll see out there. But in addition to that, it has native networking objects, so you can simply set up a web server on it. You can take requests. You're not dealing with a lot of complexity of code and how to hook up your SPI and all these kind of things. It just works out of the box.
Great. Next one is from Mark. Mark asks, do any of the latest and greatest scripting languages and environments like Ruby, Rails, Python have hooks into Arduino or Netduino?
You know, that's a question that probably requires a little bit more research because I haven't used any of those with it. There are some ways that you can use things by proxy, or you can write an app on your desktop and talk via networking. But in both the Arduino and the Netduino worlds, typically you're running C code in the case of Arduino, using the Arduino derivative of the C language, or C# or Visual Basic on Netduino. So generally it would be no, but there are ways to make things like that happen.
Thank you. Next one from James. Are there any resources you can recommend for stacking? Does your book, Getting Started with Netduino, cover this?
I'm not actually sure what that question means. James, can you ping me offline, or can you post that on the Netduino forums? We'd be happy to answer that question.
Great. Our next question is from Randall. Randall asks, does Netduino use the same programming code as Arduino?
No, the answer is no to that. Arduino uses is basically C code, which is your typical microcontroller language with some nice libraries that make it a little bit simpler. Netduino is high-level languages from Microsoft C#, things that are kind of power tools, but just as easy to get started with here. Thank you.
Jose asks, when will the Getting Started with Netduino book be updated with Netduino Go topics?
So we will actually start in the next month or two posting samples that work with Netduino Go that work with the book so that you can use your book and you can follow along with the samples that are updated for Netduino Go. They're not going to be a lot different, but as far as the book being updated, we'll probably do a revision of the ebook this fall.
Great. Let's see here. Luciano's next question asks, I thought the .NET platform was language agnostic. Why is C# supported and Visual Basic not? I'm wondering because I'm actually interested in using IronPython.
So, Luciano, that's actually a great question. Visual Basic is now supported. IronPython, I believe, requires the DLR. Fabian, do you know more about IronPython that you could pitch in on this question? As far as its requirements of DLR or not? Do you know? I don't know.
We haven't used IronPython on the Netduino, but you could actually, there was a previous question about other languages, and you could actually run straight up Python on a Netduino if you just blasted the .NET Micro Framework in the CLR, but it's a different approach.
Oh, that's a really good point.
As far as IronPython, never tried it.
Yeah, it's not obvious that it would run on Micro Framework. One would have to try it and fix any programs. I wouldn't expect it to work without a lot of work.
I know that PyMite will work, though. And you could actually run Python using PyMite for the ARM Cortex.
So actually with what Fabian was just talking about as well, you can wipe everything off the Netduino. There's an erase feature because it's fully open source. You can wipe everything off. You could actually run free RTOS, or again, you said a Python version there. That's a great point.
Thank you. Let's see here. Next one from Wayne. Will the .NET Micro support on Netduino Go use the native float point unit that exists on the STM32 Cortex M4?
So the microcontroller on the Netduino Go is an M4F, which means it has an integrated floating point unit. That's one of the things we're targeting. I'm not sure that we're actually using that quite yet. That's largely a compiler feature, but there's no reason that we can't use that floating point that's in there to give you excellent precision and to also give you, offloaded microcontroller cycles with that.
Okay, and one from Jason here. Is there an Ethernet board for the Go?
There is. It's not out yet. We have a little surprise. We're using a brand new microcontroller that I think people are going to be really excited about, and we're just waiting for them to come in. It was so new. We got some of the first chips. It's going to be out in the next month or two-ish, though. We're just waiting on the parts to come in, and I think people will really like it. It's going to be it'll be faster than Netduino Plus. I'll leave it at that until we see the final speed, but I think people are really going to love it.
Great. And our next question is from Ilya. What Netduino board has the least power consumption?
That would probably be the Netduino Mini because it doesn't have a power LED on it. Although if you ran the Netduino Go at a really low power, really low frequency, so it's not running as fast, maybe at 30 megahertz, which is equivalent to what like a Netduino would be. Turn off the LED. It might actually have a lower power consumption even than the Netduino Mini. All of these chips are really pretty spectacular in the area of low power consumption.
Thank you. Let's see here. Next one from Randall. Are there any relations between Netduino and Arduino? They look and sound very similar. Was Arduino used to derive Netduino?
Actually, the other way around kind of. Netduino isn't a derivative of Arduino from a hardware sense. They're almost completely different, but they do use the same form factors, and the Netduino is designed to be electrically compatible with almost all Arduino expansion boards. When we designed Netduino, Arduino had actually been out for a couple of years, and we wanted to make something that was both network-enabled, developed for the software developer and the education crowd, but was also taking hardware to that 32-bit level. And we wanted to make sure that all those people who were creating open source hardware for their day jobs could or even not for their day jobs, could quit their day jobs and could start making it full-time, and we could increase the size of that ecosystem rather than competing with it. We wanted to enable people.
Thank you. Let's see here. Next one from David. David asks, any plans for a Mac-based development environment?
So, speaking of open source, actually MonoDevelop is a really reasonably nice IDE for Mac and Linux. They've already taken the compiler and done a lot of great work to make the compiler work with .NET Microframework. And there's manual instructions right now where you can actually write code on the Mac using your favorite code editor, compile it, and actually put it onto a Netduino Plus, or now a Netduino Go. There's some work that's out there being done. It's a volunteer effort, but if anyone would like to help pitch in, this is a great call for that as well. We hope to have MonoDevelop actually fully supported with .NET Microframework so that you could write code natively on a Mac. Right now, most people just use Oracle VirtualBox and buy an older version of Windows XP or a version of Windows from their old computer that they're licensed to use under it. All the
Thank
tools
you.
are
Our
free.
next question from Ken. Ken would like to get more information on the CNC project that you referenced earlier. Is there a link you can direct him to for more information on that?
Yeah, so if you go to the forum and search for CNC, or go to Google and type site forums.netduino.com/CNC, Darren, D-A-R-R-I-N, it'll bring up the thread on that. You can also go back in this presentation after this call. It should be archived at some point here. The link to the video is actually at the bottom of that, and I'm hoping the video has a link back to the website, but it's in the forums. Darren actually documented parts of his project.
Great. Let's take a peek here. More questions coming in. Thank you, folks. Jason, what is the cable length limitation between Go and the modules?
Right now we're using 5 centimeter and 10 centimeter cables. There's a 30 centimeter cable. If it works well for you, that's great. Most of the modules have CRCs built in, and we'll be updating all the modules soon to have CRC integrated. What that does is it makes it so that we can detect if there's any errors across the cables. So instead of you getting data corruption, we can simply just downgrade the speed a little bit so that you get slower throughput. In theory, the cable can be whatever size is reasonable to keep the voltage above like 2.7 volts or whatever the minimum is. We could calculate that in the forums if you'd like, but it's chassis wiring, so you're not going to get beyond maybe a couple feet. If you want to go beyond that, grab a XP connection and 2 Netduino Go's and talk between them.
Perfect. Let's take a peek here. Dennis would like to now know, where can I find a list of classes that are implemented in micro.net? I can't find any summaries.
Netduino.com, downloads page, and the second link down, I think, on the downloads page for documentation is a full reference guide for the .NET Microframework with all the classes implemented and details.
Great. I have a question from Annie now. She asks, if you were to compare a Netduino to an early PC, 8086, 286, where would it come?
So the Netduino Go is the newest one at 168 megahertz, so it's Pentium class or Pentium 2 class. But it's an ARM microcontroller, a little bit different. The biggest difference is that Netduinos have very small amounts of storage space and RAM, so it isn't really comparable to a PC in that spectrum. It'd be more like a 8086. But as far as speed goes and capabilities, you're way up there in the Pentium Plus class now.
Okay, next question from David. Any plans for an analog plug-and-play board, synthesizer, building blocks, etc.?
So Pete Brown actually has already done a mini module for Gadgeteer, which, because we have SU and X compatibility for Gadgeteer modules built in Netduino Go, works with it today, and I know he's working on a Netduino Go version. There's a whole community of people. I think that's an excellent idea. If that individual wants to work on it, that'd be great. I know we have some analog type modules coming to us at Fabian, Bertrand. Do you have any comments on that?
Yeah, we have identified a number of things that would be really useful for people who want to build using simply breadboards and have generic modules that they can adapt to different types of tasks and interfacing with different types of sensors. So it's definitely something we're working on right now.
Awesome.
Thank you. There's a few folks asking about the new microcontroller. Can you talk any more about that?
So the new Netduino Go uses this amazingly fast STM32F4 microcontroller. It's the new Cortex microcontroller family, which means that you actually get more than one instruction process per clock cycle. The bottom line is it's fast. It's 4+ times as fast as the original Netduino microcontrollers. For most applications, speed doesn't matter, but when you're doing calculations, speed never hurts. There's a lot of cool things you can do with that extra speed. It also has something called core-coupled memory, which is this really fast type of RAM that we can store our buffers and our stack in. We're getting a little more technical here, but it allows us to do a lot of cool things to give you more space to run your code and more speed behind the scenes. Plus, with the GoBus technology, we can use external chips of that same type like we do on the Shield base, or as the 8-bit cousin, or even an AVR if you wanted, to expand its capabilities out from there. There's no code porting issues, though. I see someone had asked that. I'll answer that before we can get to that question. We made sure that Netduino is forward and backwards compatible. In fact, with the new Netduino Go, we're adding some classes to make it so even the book samples from the original Netduino will work with the Netduino Go. Perfect.
Oh, big question from Wayne here. Wayne asks, okay, Netduino Go uses a ST Micro STM32 ARM Cortex M4. The Netduino Basic uses the older ATmel ARM M7. Are there any code porting issues that come up when migrating from the basic Netduino to the new Netduino Go?
No, there shouldn't be. It should be a seamless transition. Netduino Go's only a week old, so you never know. There might be a few little things. If there are, just let us know and we'll take care of them. But we designed Netduino Go so it was a seamless transition both up and down for your code. Obviously, you can't plug a Go module into a Netduino Classic, but anything that you could do on Netduino, you should be able to update it to a Netduino Go simply by plugging the stuff in. You might have to tell it you're on a Shield base, instead of a direct pin, but that's about the extent of it.
Mike has a question. How does the memory management work on the Netduino?
So, Fabian, do you want to go into this? I mean, I can go into it, but you're an expert. You and Bertrand actually are experts in .NET. Do you want to talk about how garbage collection works?
I could talk about, well, sure. I mean, either of us. Are we talking about the garbage collector here, or is
just
there
how
more
memory works and how you don't have to worry about allocating objects and cleaning them up, how .NET works generally?
Yeah, so .NET, like Java, is a managed language, a managed framework, and everything you have to do in C to manage memory, well, you pretty much don't have to worry about on .NET. you kind of trade that for different concerns. So you may have some memory management issues in some cases. Let's say that most of the time you just don't worry about it. You just allocate stuff. It gets garbage collected. In some extreme cases, you may have issues with that because garbage collection has its limitations.
And it's unpredictable.
But most of the time, it's a million times easier on the managed platform than in a C-like language. Yeah. So that's what I would say about it.
So, but it automatically prevents memory leaks and all those kind of nasty things you have to worry about managing your memory.
That's right. There's one nuance though on the .NET micro framework. I think people coming from the desktop who are using the micro framework tend to forget that the microcontroller doesn't have the same amount of resources. It's almost deceiving. So you need to be a little bit more careful about how you new the objects, and sometimes you have to know when to call the garbage collection to avoid some low memory problems.
What, no 20 megabyte buffers?
Well, you could, but
I would add that it takes some. I mean, you might want to change some of the habits you took when developing for the desktop. You might want to make sure that what you allocate is reusable by your code. So it's kind of different practices that you apply in your programming. The best practices are different from the desktop. You will want to have some more centralized objects that you reuse more than just carelessly allocating objects and destroying them. But essentially, it's way simpler than anything you could have in a non-managed language.
Yeah, you don't have to do mallocs and deletes and things like that all the time at all.
You just need to apply common sense, I would say.
So I see, Yasser, there was another question about when the garbage collector runs, and we should probably tie that in the same conversation. The answer to that is it runs whenever it needs memory. The way the micro framework works is it allocates memory to you whenever you ask for it, and then if you run out, there's not enough in a contiguous space. It garbage collects, it goes, and it gets rid of anything that's not being used anymore, and it might move a couple things around. That's when the garbage collector runs. Fabian was referring to that earlier, that that might take a few milliseconds, maybe even a quarter of a second. I don't know if it would take that long, but you might get some unpredictability if you're creating a lot of stuff, and there's ways around that, but it's usually not a big deal.
I would add to that garbage collection is something that's been around for a while. It's something that's pretty much mastered today. And there are different generations in garbage collection. You talk about generational garbage collection, where you have short-lived objects that get collected very fast and very often, and then you have longer-lived objects. And I think in .NET there are 3 generations. And the way those generations are tweaked depends on the target for the compilation. And for example, you don't collect your garbage the same way on the server as you do on a microcontroller. So all that is optimized for the specific target that you have.
Simpler is good on micro framework. I love that. Simpler is good. Yeah, I'm glad we don't have the generational. It just makes it easy. But although that'd be a neat feature. Yeah, were there any other questions on here? I see a bunch. I don't know if we have time.
We are starting to wind down on time. We can just take a few more questions, folks. Let's take one here from James. James asks a technical question. What kind of frequencies, speeds can the interrupts work on Netduino? And are interrupts executed on their own thread so they're non-blocking?
So the answer to that is very fast. It's in the megahertz range, and on some of these microcontrollers, it's almost as fast as the microcontroller itself is. And the nice thing about interrupts on hardware pins is that generally they happen in the background. So when a signal comes in on a hardware pin for an interrupt, you're not actually using code to pull those and see what's going on. It happens in the background. It gets queued up. It gets raised in your code. And, yes, it does get raised on an event. You can do that in a multi-threaded environment so that they're not blocking.
Okay, and our final question is from Eric. Eric asks, are there any plans for a display module supporting resolutions higher than 320 by 240? And how about a VGA or HDMI display option?
I know who that question's going to. Fabian, Bertrand.
Yeah. So not at the moment. I mean, here's one thing that needs to be well understood is that we're working over an SPI bus, and to manage displays that have high resolution, well, it's not ideal. So there are some constraints that we are living with, meaning that a serial bus versus a high parallel bus that would be required to manage very large resolutions with a lot of pixel, depth per pixel. So there's no plan for that right now. I think if we were in the business of building, Xbox 360s, we would take a very different approach. But this is not exactly the point of a microcontroller. It's not a gaming machine. That's what I'm trying to say. So what we can achieve right now is really awesome versus what we could do with much simpler microcontrollers, but high powered displays and large resolutions. It's going to be a little while, and it's going to take several generations of the Netduino before we get there.
Right. If you want to play video, for instance, you'd end up making a display component which stored the video locally to pipe it directly to the display. Much like the Blu-ray players might have a dedicated stream between the actual Blu-ray decoder and the HDMI port interface that's inside those. Anytime you get to the big displays, parallel interfaces, you're really amping up either the number of pins or the speed of the megahertz, or you're creating dedicated buses for them.
So I would add that there are boards out there that are not Netduino, but there are boards that are able to manipulate high-definition video. It's a completely different kind of story.
It's very dedicated. There is no traffic over a bus. It's all the board does it all. That basically.
Yeah.
Yeah, it's a dedicated display bus. If that's something you'd like in Netduino, we're certainly open to adding that in the future. But we haven't had a lot of feedback saying that the cost of that is really something people are willing to incur.